Okay, CBI students. This is just to give you a bit of an idea what the anaerobic digestion setup will look like. I want you next week, your babies will be delivered to your lab, the third year lab on the second floor on Engineering 2. And since you'll be the caretakers of the babies, you need to get thinking about them, and what it will entail. So this is just a bit of a teaser. Next week, you'll see the reality. This is a picture of our 10-liter digester. And very important, I'm going to talk a little bit more about how this one works. But remember, this project is all about building bigger digesters on the outside in African townships. So we're going from 10 liters to 800 plus liters to make enough cooking gas for those communities. So remember, your project, even though it's on a small reactor and we're not going to cook with the gas, we're just going to measure the content of the gas and the amount of gas produced with a few other things. But all this work is contributing towards developing a digestion culture in African settlements where we use food waste. You'll see you're going to prepare your food smoothies or slurries yourself. So just keep in mind, and there'll be links to the work that Mfundo is doing on the bigger bags. But for now, it's going to be small transparent white bags, small transparent bags, and not the black bags that we're going to use on the outside. So let's get on. Okay, so here we get an idea of what your 10-liter reactor will look like. 10 liters refers to the liquid and slurry volume. If you have a look at your digester, you will see there's 3 pipes that goes into the vessel. There is one plastic bag that just actually tightens around these outlet pipes. One pipe, and this is the pipe we're going to feed new slurry. So we're going to use fruit and vegetables, make a nice smoothie, and then feed it in through here. But before we're going to do that, we're going to use this same pipe to extract a bit of liquid from the reactor. So in a sense, even though this is happening only every second day, it is like a continuous feed where there's removal before you have addition. Some of the reactors will also have a pipe that goes directly into the slurry. You remember the recalcitrant fraction, so not all of the vegetable waste will be digested to make gas, and there'll be a buildup of slurry. So we'll, through the semester, develop a strategy to remove slurry from the reactor from the second pipe. And then the third pipe is the biogas collection pipe. You'll see that this pipe is actually connected to the top of the bag, and so that liquid can't get there. Gas flows in there, and you might ask yourself, but what will be the pressure in this bag? Well, the pressure in this bag will be revealed by the head that it pushes up into this section where the 3 pipes are binded together. So this head is typically going to be in the vicinity of about 20 centimeters. 20 centimeters of water is 2 kilopascals. And that will give you an idea of the pressure. And from the next slide, I'll show you how the pressure is going to be regulated. Very important. Why is the reactor tilted? We need the liquid seal. That just implies that gas collecting over here should not be able to escape through here, because over here we don't have a perfect seal. It's not sealed on this side, not sealed at all. And the liquid in the reactor actually causes a liquid seal, so that biogas can't escape on this side of the reactor, but all of it will escape through the tube. It's an orange tube that runs through the reactor and out. So as soon as we make biogas, we can't release it into the lab. We've installed a whole extraction facility for your experiments. So this biogas now goes to a gas collection device, which will be the next slide. So this is exactly, we've produced biogas in the previous slide. Now we're just taking it through a pipe into a collection device. You've got 10 liters of capacity that you can collect in, and it's merely simple 10-liter polypropylene bottles that is upside down, or the collection one is upside down. So this bottle and this bottle is exactly the same. The upside down one is in a cutted 20-liter bottle that we fill with water, and there's an overflow. There's an overflow at a certain height. That means the water level can't get higher than the overflow. So what will happen is you will bubble the gas, and the nozzle will be at the bottom of the bottle, and as time progresses, more and more gas will collect. We will shut off this valve. We'll only use that for measurement or for purge. I'll talk a little bit about valves later on, but get the picture. As more gas collects over here, the level will go down, and we will effectively have the same liquid or water. The blue is water. We have the same water volume that gets displaced into the collection vessel. So this gives you the amount of gas that form, even though you measure it in volume of water. So this is very simple. We can just weigh this mass, and then over every 24 hours get a good idea as to how much gas has formed. So from your gas outlet, I talked about a purge or measurement stream. You'll just connect a little tube to this device, which will give you a reading on methane, CO2, H2S, oxygen, and also on the remainder, it's called nitrogen, but it's just it's just an indication of how much nitrogen is in, or how much unknown gas is in the system. So Mfundo will be operating this, but every second or every day you will take a biogas measurements. So it's not just about measuring the amount of biogas that you form, but also the composition of the biogas that you form. There'll be other measurements of the liquid, but I'll get into that later. And then lastly, let's just talk a little bit about the tubes we're going to be using. You'll see there's two tubes that are the ones completely transparent. That'll be a PVC tube. The one you can see water flowing through it, it's a silicone tube, much softer, much squeezier. And this tube is also semi-transparent. This is the one we will use for shutting off gas pressure. Very simple. You can see on this side, the only thing we do is we bend the pipe. It's nice and bendy, and we just use a big paper clip, and that is a perfect shut-off valve. You'll be using paper clips a lot, and you'll have to ensure that you use your paper clips at the right time so that the right valves are open and the right valves are closed. With regards to the PVC, we don't want to do this pinching of the PVC. It doesn't have the elasticity. So I don't want to find you pinching a PVC that's the perfectly transparent tube. Then we use some other tubes for the gas. We will use the orange tube for the gas collection from the bag itself. And we'll use the blue tube just for liquid displacement in the picture that I've just shown you before. Okay, so this gives you an idea of what's coming. I just wanted to put it in your brain for now. Next week, you'll be seeing all of this in practice. Okay, cheerio.